Hi everyone, welcome to AI News Hub, and today we're going to talk about the world of robotics. When AI exists in an physic bionic structure or mechanism, obeying the laws of physics. And in this video most specific, when the creation of this robots is inspired in wildlife, mimicking animals with amazing capabilities to build robots capable of doing extraordinary things. But before starting, don't forget to like, subscribe, and put on the comments some of the robots you've heard about before. We would be glad to hear you. First up, the robot Digit from Agility Robots that is now being used by Amazon and other companies. The Digit robot from Agility Robotics wasn't directly modeled after one specific bird species, but its design principles were heavily inspired by bird-like movement and anatomy, especially bipedal birds such as ostriches and emus. Birds like ostriches have long, spring-like legs with reversed knees that allow efficient forward motion and energy recovery. Digit's legs mimic that same structure, giving it natural balance and walking efficiency, which makes it ideal for uneven ground and stairs. Birds keep their center of mass close to their hips for stability while walking or running. Digit follows this principle, allowing it to stay upright even when bumped or carrying objects. Instead of stiff robotic walking, Digit moves with a smooth, bird-like gait, using momentum and balance rather than brute mechanical precision. This makes its movement feel more organic and efficient. Like birds that rely mostly on leg motion, Digit doesn't have bulky arms, just lightweight manipulators designed for balance and grasping tasks, again mirroring avian efficiency. So in short, Digit walks like a bird, not a human, and that's exactly what makes it so agile and stable for logistics work. Amazon is currently testing the Digit humanoid robot, developed by Agility Robotics, in its warehouse operations to assist with repetitive tasks. As of November 2025, the robot has evolved beyond its initial role of moving empty tote boxes, now performing expanded duties such as sorting, picking up, moving, and arranging warehouse boxes. The robot, standing 5.7 feet tall, is designed to navigate human-designed warehouse environments autonomously, using cameras, sensors, and a bipedal structure that allows it to move in multiple directions, crouch, and handle items up to 35 pounds. Next up, we have the Bionic Handling Assistant, inspired by an elephant trunk. An elephant's trunk manipulates objects using a combination of strength, dexterity, and specialized techniques like fingers at the tip for pinching, wrapping around objects, and suction. It can also create pseudo-joints and use bending and twisting to grasp objects, and its high degree of sensory input allows for both delicate manipulation and the application of great force. This robot does the same, a robotic arm that can grasp delicate or heavy objects smoothly. It basically lifts like an elephant, but with surgical precision. In conclusion, the Bionic Handling Assistant is a robotic arm developed by Festo, inspired by an elephant's trunk, that uses compressed air to move. Instead of heavy metal parts, it is made of lightweight plastic and contains a series of air chambers that inflate and deflate to bend and extend the arm, making it safer for human-robot interaction. The design allows for a high degree of flexibility and smooth movement, mimicking the dexterity of a real trunk for picking up and manipulating objects. And now let's talk about the infamous, smart, and mysterious octopus. The Octobot is inspired by the octopus through its all-soft, autonomous design and soft, fluidic-powered locomotion. Its creators were inspired by the octopus's lack of a skeleton and its ability to achieve complex movements using a muscular hydrostat system, which is mimicked in the robot through flexible chambers filled with gas that inflate to bend its arms. While the original Octobot was a tribute to the octopus's form, later Octobot projects have focused on more specific inspirations, such as using wave-like arm movements to capture prey. A soft, squishy robot with no hard parts runs on chemical reactions instead of wires or motors. This soft robot moves without metal or motors, just like an octopus. Entirely soft robot developed by a team at Harvard University, led by researchers Robert Wood and Michael Weiner. Announced in 2016, this robot was inspired by the octopus and constructed entirely from soft materials like silicone polymers, with no rigid components such as circuit boards or batteries. It was powered by a chemical reaction between hydrogen peroxide and platinum, which generated gas to drive microfluidic channels, enabling movement without electronics. This groundbreaking prototype demonstrated the feasibility of untethered, soft-bodied robots and was a significant milestone in soft robotics, a field that saw rapid growth from nearly 0 academic papers in 2004 to nearly 1,000 by 2016. The project was supported by DARPA's Maximum Mobility and Manipulation Program and built upon earlier work from the Weiss Institute. Now let's talk about a robot inspired in a penguin, Penguins are known for their flightless nature and exceptional swimming abilities, using their flippers to fly through the water at speeds up to 15 miles per hour. Their distinctive black and white coloration, known as countershading, provides camouflage. Underwater black backs blend with the deep ocean when viewed from above, while white bellies match the bright surface when seen from below. The Festo Aqua Penguin is a bionic robot inspired by the natural penguin, designed to autonomously navigate and maneuver in water. It uses hydrodynamic body contours and a wing propulsion system modeled on real penguins, allowing it to move efficiently through tight spaces, turn on the spot, and even swim backwards, something real penguins cannot do. The wings are constructed with spring steel elements embedded in an elastic silicon matrix, enabling them to twist to an optimal angle during each stroke and adjust their pitch for precise control. To navigate and avoid collisions, the Aqua Penguin employs a 3D sonar system that uses broadband ultrasonic signals, similar to how dolphins communicate and perceive their environment. This system allows the robot to determine its position in space, measure distances to boundaries, and maintain positional stability. It also features a pressure sensor for depth measurement in open water. A key innovation in the Aqua Penguin's design is its freely moving torso, based on a bionic fin rabe structure derived from a fish's tail fin. This 3D extension of the fin rabe structure allows the robot to bend around pressure points rather than simply deflecting, enabling highly flexible and adaptive movement. This flexible hull design has potential applications in automation, particularly in creating flexible parallel kinematic systems for handling technology. This penguin is not from the Arctic, it's from the lab. Now a scary robot inspired by the infamous, devil-looking snakes. Snake locomotion is a complex and versatile process that allows snakes to move efficiently across a wide range of terrains without limbs. The primary mechanism involves the use of friction and muscular contractions to generate forward motion, with different modes of locomotion adapted to specific environments and surfaces. The most common form of locomotion is lateral undulation, also known as serpentine locomotion, where the snake moves in an S-shaped pattern. Snakebots are designed for a wide range of purposes across multiple industries due to their unique ability to navigate complex and confined environments. In search and rescue operations, snakebots have been deployed to locate survivors in collapsed structures, such as during the 2017 earthquake in Mexico City, where they transmitted video from tight spaces where human rescuers could not enter. Their small cross-section to length ratio and ability to change shape allow them to maneuver through rubble, pipes, and other narrow passages. In industrial and infrastructure maintenance, snakebots are used to inspect hard-to-reach areas such as pipelines, bridges, offshore oil rigs, and fluid-filled tanks, where traditional inspection methods are impractical or dangerous. Their modular, jointed design enables them to squeeze around corners and into confined spaces, making them ideal for assessing structural integrity without requiring disassembly. In the medical field, miniature snakebots are developed for minimally invasive procedures, including endoscopic surgeries and targeted treatments within the human body. For example, a medical snakebot from Carnegie Mellon University can navigate around organs inside the chest cavity, allowing surgeons to perform operations through small incisions, reducing patient trauma and recovery time. These robots can carry cameras, forceps, and sensors to diagnose and treat diseases within blood vessels or internal organs. So, which one of those is your favorite? And what do you think of the world of robotics? Is it scary? Could they pose a threat to humanity one day? Or could they help us alongside in all different fields contributing to our development? Please, comment below and don't forget to like and subscribe. See you next video. Have a great day.